All right, ladies and gents, let's continue. Now we're going to abstract even further from, so in the previous video I talked about three number classifications, if you remember. They were the integers, the natural numbers, and the whole numbers. And I'll just quickly recap that here. So a natural number is any number like 1, 2, 3, 4, so it's a counting number. A whole number is just the natural numbers with the addition of 0. An integer is the whole numbers, so from here on out the whole numbers, plus the reflection of the positive numbers, which give you the negative numbers. And a negative number is the opposite of a positive number. And one way you can think about this is try to do 1 plus its opposite, 1 plus negative 1. That's just the same thing as saying 1 minus 1, right? And what does that give us? 0. 2 plus negative 2 gives you 0. So it's like the mirror, it's the opposite. It's what you add to, you add the mirror image to it and it cancels it out. It gives you a 0. So it kind of like destroys the number. It makes what that number is, you add the negative of it and it gives you 0. It's a terrible explanation, but that'll do for now. Okay, so now let's introduce what a rational number is. So we're going to go over the definition slowly, and then I'm just going to say it, and then we'll give you some examples. That way it'll be more concrete. Because in math you're going to have so many definitions that don't make sense when you first see them, but then you have to start to deconstruct them and then actually put them into reality. You have to say, okay, give me an example of what you're saying, what you're talking about. I'm going to do the same thing here. So a rational number is any, I'm just going to write short for number and stuff like that. So a rational number is any number which is written a over b, and I'm going to tell you what a is and what b is. Where a is an integer, b is an integer, and the only thing is b cannot be 0. So let's deconstruct that and see what that's saying. So a rational number is any number in which the top number can be an integer. So a in the numerator of the fraction could be 0, 1, 2, 3, sorry, negative 3, negative 2, 1, 2. It could be any integer on the top number. The same thing at the bottom. The bottom could also be an integer. The only thing is b cannot be 0. So let's give some quick examples. Okay, so let's look at the first one. The first one says negative 3 over 2. Is that a rational number? Let's look at the definition. The top number has to be an integer. It's negative 3, that's fine. The bottom number has to be an integer. So b has to be an integer, which is the bottom number. And 2 is an integer. So both of these numbers are an integer, and b is not 0. So yes. Let's look at the next one. The top number is 2, which is an integer. That's fine. The bottom number, 3, is an integer, which is fine. Is the bottom number 0? No, it's not. So the top number is an integer, the bottom number is an integer, and the bottom number is not 0. So that, as well, is a rational number. Let's move on to the next number. The top number is 3, the bottom number is 0. So the top number is an integer, the bottom number is an integer, those are both fine. Top number is an integer, bottom number is an integer. But is the bottom not 0? Well, the bottom is 0. So in this case, this is not a rational number. Again, let's look at the last example. So the top number is 1, bottom number is 0. Is the top number an integer? Top number is top number an integer? Well, 1 is an integer. The bottom number is an integer because that's 0. But again, it fails to satisfy this condition, which says that b cannot be 0. In this case, b is 0, so it's not an integer. And if you're asking what's the big deal, why can't the bottom number be 0? In math, anytime you have any number, so I'm just going to write, you can write any number here at the top number, but I'll just write 4. You could have wrote 3, 2, 1, negative 5, 10 trillion, over 0. So anytime you have this fraction where you have 0 in the denominator, remember the top number is the numerator, the bottom number is the denominator. Anytime you have a 0 in the denominator, we could say that this is undefined. So you can't do this. It's not allowed in math. So that's why 0 can't be the bottom. Okay, in the next video, I'm going to show you how, just like in the previous video, I told you how you had the natural numbers, then you had whole numbers, then you had integers, and as you keep abstracting or you generalize, each number classification below is contained. So how we had the whole numbers, sorry, the natural numbers, the counting numbers, the whole numbers, let's just repeat this. So if you remember, just a quick recap, we said that these are the natural, these are the whole, these are the integers. The natural numbers are contained in the whole numbers because as you can see, the whole numbers is basically the natural numbers with 0. The whole numbers are contained in the integers because if you just looked at this side of the equation, this side, sorry, of the numbers, it contains the whole numbers. But in addition, the integers contain the opposites. So this one contains this and this, as you can see, because any number that's an integer is also a whole number, and any number that is a natural number is an integer as well. So you can see how we're generalizing, and we're saying this class contains all these numbers. And now, in the next video, I'm going to talk about how the rational numbers contain the integers, which contain all these numbers. So that's pretty cool.